Yeah, it's my next shiny object. I have this shiny object syndrome. I see something and I get stuck in it. I saw a crow meme over on the meme channel a while back that kind of fits perfectly sometimes. Shiny object, pick it up and go with it. Anyway, ADR, adaptive data rate, was just brought in. So I've been playing around with that. I had played around with it on CubeCell a while back, and now that it's live, I kind of wanted to see what was going on with it. But I kind of have some questions on not just ADR, but the join process and what is best practices, I guess, with the network. ADR is there's two pieces to it. One, if you're not familiar, one is you have to enable it within the functions, labels, I'm sorry. Within the label, there's a place there to enable ADR on the console. That tells the network, hey, I want to enable adaptive data rate. The other piece is that the device application has to also enable ADR at its side so that the uplinks, when they go up to the network, there's a bit set in the MAC header somewhere that tells the network, hey, I want you to adapt my data rate. So once that's enabled on both ends, then the network will count about 20 uplinks and it's taking statistics. And I don't know what all is involved in that algorithm, but it tries to recommend to the device application an optimal data rate and power setting with the intention of preserving battery life and reducing activity over the air. Anyway, that's ADR in a nutshell. And that from the network side, that seems to work fine. After 20 uplinks, I do see the suggestion come back down. Sometimes it's 2 messages, sometimes it's 3 messages. And I know that's still being worked on. The runtimes I've looked at, the CubeCell and Weezblock, they seem to handle that okay as far as changing the data rate. And I'm not sure about the power. I haven't delved into that much at all, but that seems to be also seems to be working. So I think from a console point of view, I think the ADR aspect is working fine. As far as, I'm real close to my hotspot. My device says, hey, I want to use data rate 1. Network keeps track of statistics and says, hey, you really could use data rate 3 and reduce your power usage because you're close enough to the hotspot. Now, what happens if I connect and I'm good with data rate 3, but what happens if I move away from the hotspot or my local hotspot goes down and I have to connect to another one? I'm not sure what's going to happen there at this point. I don't have a good Faraday cage to test out that end of things. But I guess ideally what should happen is the network should recognize that, hey, your signal's not as good as it was before. Maybe you should switch to DR2, a little bit longer reach, maybe a little bit more power. There's an recommended algorithm there that Semtech came up with, and I don't know all the ins and outs of maybe it's increasing power before you change data rate. I'm not sure. But the whole idea is to try to optimize your power and network bandwidth as signal strength changes within your device.
So the other aspect of ADR is at the device side. The device can count, the device runtime will count how many uplinks you send and keep track of how many downlinks. Okay, so it's going to count your uplinks. If you send, for instance, 96 uplinks without a corresponding downlink, then the runtime will adapt your data rate. To me, that seems kind of a high number, 96 transmissions without a downlink. Okay, so that part is not quite gelled in my mind yet. But the whole idea here, I think, is that the device has a responsibility to request an acknowledgement from the network to make sure that the connection is still there, that the network is getting your data. So to me, it seems like a best practice is not to just continually throw it over the wall and forget about it, but throw it over the wall and periodically ask for an acknowledgement. When you get that acknowledgement back down, the runtime then should reset that counter. Okay, that aspect of it I've not done anything with at all, other than a little bit of testing, fake out testing with QCell. So I think that's ADR in a nutshell. I do have some questions about the join process, but that's not ADR related.
Some of the examples that were given for ADR is where you've connected up to a near-in hotspot. Suddenly that hotspot goes away. Well, now you've got to adapt and be able to push your signal farther. And ADR can help with that somewhat. Now, if you lose your signal entirely, then your network cannot suggest a change, in which case it's going to have to be up to your device to handle that, the device side to handle that. And I don't know that magic count of the device runtime adjusting the data rate, I think is on the neighborhood between 64 and 90 something uplinks. And I don't see where any of the runtimes that the couple I've looked at allow the device app to change that value. And I think that would be a nice thing. But
so can you comment just quickly on the what BG Tokyo dropped this morning?
yeah, a lot of that was logging API changes. And from what I could see, what he dropped was there were two things with joins that I noticed. One of them was joins typically cycle between data rates. And what I've seen is data rate, we may start off with data rate 4, and then if that doesn't join, go to data rate 3, or 0 rather, I'm sorry. And the problem with DR4 is Helium only supports one of the 7 subchannels that DR4 uses. DR4, as I understand it, has got like a 500 kilohertz bandwidth. DR0 through 3 are like 125 kilohertz bandwidth. And I don't know that Helium, when you do uplinks, I don't know that Helium supports 500 megahertz channels. It does for join. And that's kind of what I'm confused about there is why are we trying DR4 if we can't use it for uplinks? Anyway, so part of what he dropped was to change that. And what was happening originally was it would try DR4. If that failed, it would go to data rate 0. If that failed, it would switch back to data rate 4. The number of times it does that is dependent upon a pound define in your sketch. It's number of join trials, I think, is something like that. So if that was set to 3, the runtime would try DR4 fails, DR0 fails, DR4 fails. If it exhausts that count, then it just sits there. Doesn't notify the application in any way, shape, or form that the join has failed. Okay, that's an issue. The change was to try DR0 8 times. And then and only then do you try DR4. You try DR4 1 time, and then you try DR0 8 times. But again, the number of tries is highly dependent upon that pound define in your sketch. If that pound define is set to 3, it's only going to try 3 times, and then it's going to stop. So that was one of the major changes. The other major change was when you join, let's say, for instance, your device application says, I need to use DR1. My packet size is greater than 11 bytes, so I need to use DR1 or above. So I'm going to set my desired data rate to DR1. If the join was successful at DR0, then the runtime was setting the data rate to DR0. It was ignoring the device specified data rate. Well, that has been changed. One caveat there, that was only when ADR was turned on. When ADR was disabled, it was using the device specified rate. When ADR was enabled, it was falling back to data rate 0. So they fixed that. So now after the join, if you join at DR0 and the device is specified DR1, your uplinks are going to occur at DR1, or they're going to try. Now that's another one of my join questions is, if my device can only join and only communicate at DR0, but I need DR1 to successfully transfer because I'm so far away, what's going to happen? I mean, why are we even trying at DR0 if I have to have, because of my packet size, maybe DR3, for instance? So it's kind of something I don't understand how to resolve that. But I think those were the two major things that affect us. I don't think there were some Australian changes in there as well, but maybe Jose, if you could, if you know, you could correct me if I'm wrong there.
Are there standards? Go ahead, Jose.
No, I was going to say that. Yeah, I haven't checked fully reviewed the patch yet, so that's yeah.
That's the two things that I've noticed.
Leroy, are these things not defined in the standards? Like the standards leave them undefined, and so it's kind of all into consensus interpretation, or
being the novice LoRaWAN spec reader that I am, it appears to be implementation dependent. They do recommend, for instance, that you cycle through data rates on a join. They recommend you do not stick with DR0 or you do not stick with DR3, but they kind of recommend you go through all of them, but they don't, it's not a, as I understand it, it's not a requirement.
Well, and that you decrease your DR as you increment your retry.
Right. And there's a power adjustment too that they recommend. Now there's a couple of runtimes out there that start at DR0 and that's all they do. So, it's kind of up to whoever developed the runtime, basically. Now, the Semtech reference implementation did change that aspect where it defaults to data rate 0 once you've joined. That was in the original Semtech reference implementation, to where it would always use DR0 on the uplink. Semtech took that out a while back, and a couple of the runtimes have taken it out as well, and that's part of what RAC did this time. But as far as, what happened, the spec is not real clear in those areas, from what I understand.